in the log, he saw that it flatlined the boost, which is 7-bar map sensors, 80 pounds. So we told the world it made 80 pounds, even though it could be well above that. But it cracked the block all the way around below the head studs and really became a two-piece engine.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're chatting with Brent from PFI Speed. Brent has been a long-time backer of the Honda platform. Many of you may already know him. He's got a very well-known YouTube channel, and in this conversation, we go into a fairly wide-ranging set of topics. In particular, we talk about the various engines in the Honda range, the B Series, the K Series, the F20, even the H22. Talk about the pros and cons of each and why you would choose one over another. Brent also is recently off the back of competing in Sick Week, which is a drag racing challenge where you drag race your car at 5 different tracks over 5 days, and in between you have to drive from one track to another. So a little bit of a challenge there, driving your drag car on the street. And this is where you may have already seen cars towing around little trailers with everything they need to service the car and turn it from somewhat streetable into competitive drag car. The idea, of course, is to see how quick you can go on average across the tracks that you compete at. As we'll find out, didn't exactly all go smoothly. In particular, there is some social media posts that did the rounds a few weeks back where there's a Honda B18C block split in half, arguably caused by potentially a jammed wastegate. So we dive deep into what caused that, certainly some of the more spectacular engine failure photos that I've seen. Before we jump into our conversation with Brent, just a little background for those who are fresh to High Performance Academy. We're actually an online training school, and we specialize in teaching people how to tune engines, how to build performance engines, and how to construct quality, reliable wiring harnesses for your car. We also cover other topics including fabrication, race driving fundamentals, and how to optimize your car out on the racetrack. And you can take any of our courses from the comfort of your own home. To find out a little bit more about the courses we include, you can head to hpacademy.com/courses. That will give you a full list of all of the courses that we currently offer. Relevant to today's topic, we dive quite a lot into engine building as well as tuning. And of course, as I mentioned, we cover both of those topics. So a couple of courses that I think any of you who enjoy today's podcast may like. We start out with our EFI Tuning Fundamentals course that will teach you, as you'd expect, the fundamentals of EFI tuning. You'll find out how an engine works, how electronic fuel injection works, and what we're actually trying to do when we're tuning them. And you may be surprised to find out that I'd say 75% of professional tuners out there right now in the industry who are taking money off customers every day for tuning work still don't understand the information that is taught inside of that course. On top of that, we have our engine building fundamentals course as well. And I know this is a topic that a lot of home enthusiasts think that's a little bit beyond them. Most of the time we hear people say things like, oh, but I'm going to need to spend tens of thousands of dollars on tools in order to build engines. And that's actually not the case. It's actually a lot easier and a lot cheaper than you probably think. And it's within the reach of any home enthusiast, provided you've got a bit of an eye for detail and a bit of patience. So we've got our engine building fundamentals course, perfect starter for those interested in learning how to build engines. And that allows you to take your project build that you've maybe working on out in the garage or your shed to the next level, all by yourself. Really rewarding to do all of that work yourself, and we'll put a link in the show notes you can follow to find both of those courses. Also, as an added bonus, because you are a listener of this podcast, you can use the coupon code podcast75. That is going to get you $75 off the purchase of your very first HPA course. All right, with that introduction out of the way, let's jump into our interview. All right, welcome to the podcast, Brent. Thanks for joining us today. And for a start, whereabouts in the world are you joining us from?
We are from Colorado, Fort Lupton, Colorado.
You still got snow on the ground over there, or is it starting to move more towards summer, spring?
No. It's like 2 degrees outside.
That doesn't make it that appealing to work
No.
on cars when your hands are freezing, in my own experience.
Yeah.
All right, let's get a bit of background from you. So PFI Speed, from what I understand, actually started out of Parts Finder International. I believe that was the name. So how did you end up founding that business? And I mean, I guess it's somewhat self-explanatory, but tell us what you were doing.
So in high school, we were juniors in high school. A buddy of mine, Scott, and I, we started a place called Honda Dismantlers. And we were, taking Hondas apart and selling the used parts and that kind of stuff. And then, we started moving engines around and finding turbochargers and trying to blow through carbs and do all that wildness, So we kind of started there, and then it was kind of more Scott's business. So I moved along and started Part Finders, where I was basically a middleman junkyard. I didn't have the salvage yards, but I knew where they all were and what was in them. And I would just sell parts. And that was Part Finders. But then as I did that, I was still I had the Honda bug. So I was still tweaking my own car, and people were wanting things. And so I started just doing that, and I had way more fun doing it. So
the Honda bug you've mentioned, you've got, and obviously your business both then and now is very firmly centered on the Honda brand. So why has Honda been your sort of livelihood and your passion?
Once we started to play with them, they were and drive them and use them, it was just, they were just simple little cars and just fun to drive and fun to rip around.
I think the other thing that they're an underrated vehicle, I believe. For me, I think they're an excellent place to start learning to tune on, because particularly when you're getting started, they're kind of hard to break. They're a pretty robust package, even when you start adding a turbocharger. And
that's for sure.
then when you do add the turbocharger, the power that you can get out of them really is impressive without having to go and break the bank in terms of upgrading every damn part through the entire car.
Yep.
So I want to mention that. I mean, a lot of people knock Hondas. I don't really know where that comes from, but they definitely are a really good platform to get started in the sport compact industry, I believe.
I believe so too, for sure.
So it sounds like Parts Finder International, you're kind of getting the best of both worlds. You're doing the parts finding, making money off that, but you didn't actually have to get your hands dirty wrecking cars and storing a junkyard full of cars.
That's right. I mean, there was days I was at U-Pullets, and pulling parts and that kind of stuff, but yeah, it was just a lot of just running around. It was pretty cool, honestly. Yeah. I did pretty good.
In terms of your mechanical sort of background, is there anything formal in your education there, or is this entirely self-taught?
This is entirely self-taught. Like, I just had a passion for cars and wanted to understand them and wanted to know how it worked, and just dove in and just played with every little bit.
I think that's important for those listening as well, who are maybe just sort of starting out with a bit of a passion for cars and haven't really dived too far into it. I mean, this stuff it's figure outable. You don't need to be a rocket scientist. And while, yes, if you want to pursue a career as a mechanic, a formal qualification in some instances is essential, but particularly as an enthusiast, it's definitely not essential, and we do get asked that question often, so I just wanted to sort of cover that off. All right, so talk us more through the development into PFI Speed as it is now, building race cars, obviously drag-centric. That's your best known for. So
again, I love tinkering on the Hondas and stuff. And we did some engine swaps, and we actually drove out to California, went to Battle of the Imports. And that's what sprung all the drag racing and just trying to make the cars get A to B, that kind of thing. So we left Battle of the Imports and we went right to work and tried to upgrade the cars and figure that out. And, back then there wasn't a lot of engine management stuff. So we, like everybody else, were wiring the first Excel DFIs into them all, and trying to figure that out, and twisting shafts, trying to find the right crank angle. And, it was pretty hardcore trying to make it all work. But that's where we kind of started the tuning. And we were literally driving them from Colorado to California to tune, because that's the only place we knew there were dynos. So we would be tuning at JG Engine Dynamics or Harv St. Mary's dyno, and we do that over the weekend and then come back to Colorado and start racing them or
Were you the man on the laptop or the screwdriver, as it may have been, when the cars were on the dyno?
So back then, we would actually, it was Javier or Harv that would tune them, and he'd be teaching me stuff and showing me things, I didn't really totally understand that side of it yet. But then as, the trips became expensive, it was a must to learn how to do it. So I bought a dyno, which is the same dyno I still have. And this is like 96, 97. I bought those and just started teaching myself on my own car. I kind of had their maps of what they were doing, and I just kept expanding on it and tweaking it and changing things and seeing how it worked.
So talk to us a little bit about that learning curve, because 96, probably not too different to the time frame where I was sort of getting involved. And back then we didn't have the level of information that's out there on the internet now. There weren't high performance academies. There weren't YouTube videos from hundreds of enthusiasts explaining the process of EFI tuning. So how did you teach yourself? What did you go through?
Honestly, I still didn't blow up a lot of stuff, but I varied that stuff and just saw what it did, checked plugs, looked at power numbers. I still never understood the engine being choked out by exhaust housings or things like that. You don't really know that stuff, but you start figuring out how to fuel it. We still weren't using because back then that Motec wideband, like some of those shops in California had, that was a couple $1,000s for that sensor, and you couldn't afford that. So we'd make short pulls up every 500 to 1,000 RPM and then read the plugs and just keep going. And that's how you do it.
That's a really interesting aspect, because I 100% agree. Back when I was starting out, unfortunately widebands were just not affordable. There was a couple of models, and you were talking, as you say, $2,000 to $5,000 for a lab grade wideband. You can buy a decent quality wideband kit now for probably a couple of $100 US. It's a very different world, and people getting involved these days probably just don't know how lucky they are. But this brings me back to this plug reading. And there's a lot of controversy around this. We've done a few posts on this as well. And there's guys out there who've basically tuned everything and anything, faster than I've ever gone down the drag strip, and all they've ever looked at is a set of plugs. So you can't say it's not a valid technique. These days, I like to say that with the level of data we've got from quality widebands, exhaust gas temperature sensors, lambda per cylinder, etc., the list goes on, I'm primarily using that as my guide. But the part that's probably easy to overlook is, particularly when I was tuning anything that was a pretty high specific power output, like our old drag car, for example, literally every pull, at the end of the pull, we'd be pulling the plugs and still having a look. And it's a case of combining all of that information, what we're learning from the dyno, what we're learning from the wideband, but still, those plugs do give you a lot of insight into what's happening inside the cylinder. So
yeah, it's a great sensor.
It is. And at the pointy end, I think it's still important not to write it off. I think where people get confused, though, is they want to read the plugs that are done 100,000 miles in their stock car that are all carboned up, and obviously it's a joke. You need to start with a fresh set of plugs. There's a process to go through.
Yep, every time, for sure.
Obviously, in your career, just like mine, you've seen the improvements massively in terms of the quality of the electronic options we've got available. I like to just mention, because I did do quite a lot of work on Hondas back in my earlier days, and I'm almost embarrassed to mention this. I had a good friend who had an EG Civic, and we did a turbo conversion on that back before we had ready availability of standalone engine management. And the way we got this to work, and I share this story just to show that there are options out there. Would I do this now? Absolutely not. But there are options out there, and what we could get away with, and maybe just how robust the Honda platform is. So on that, they handled the mechanical turbo installation. I didn't do anything with that. And the only options available to us there, we used a Hobbs switch and an extra injector in the intercooler pipe pre-throttle body. And we retarded the base timing everywhere until the thing didn't knock with 5 or 6 PSI of boost. and that was it. And that thing ran for about 3 years until it ended up getting proper engine management on it. So it's an ugly solution.
That's pretty good.
You know, when needs must, that's what we got away with. So these days things have changed, obviously. So
much.
So talk to us about what you've seen as the key advantages from modern engine management.
Oh man, I mean, it tells you, like you just said, the logging capability, having all the sensors at your fingertips, knowing what's going on in the engine. I mean, that's huge. I think the modern engine management I think even now we're still developing that technology, and pretty soon I think we'll be able to have management that's even better than what you got stock. In that, I mean, I know we're going to talk about the EPA later, but one of their big things is NOx, you know, and those sensors are becoming cheaper, and we'll be able to read that, and we'll be able to tailor everything around that, as well as like we do a wideband. And
so just for those who maybe glossed over that term NOx, we're not talking about NOx, you're talking about oxides of nitrogen. So it's an emissions output.
It's an emissions output, right? Which is, you know, the big kicker in all the gas engines, which, you know, some of it's kind of the fuel we use too. But yeah, I mean, I think as that technology grows, this stuff will get cleaner, and we can continue to make, you know, the good power we want to make and make this stuff even better.
Yeah, I mean, this might probably be as good a place as any to segue into the EPA, because you're very well known for being one of a number of smaller shops that has unfortunately incurred the wrath of the EPA for some reason, and I'd like to maybe get you to give us your story on how that actually sort of panned out.
Again, I was out at doing a tune out in California with another YouTuber, and I was helping her out, and the shop received a certified letter. It's called a 208 letter. So, you know, anyone getting that, just get a lawyer right away. I did not. I went and I filled out all their paperwork, tried to do the best I could, making sure everything was right. I didn't think it was a negative thing. I figured it was tracking parts or something along those lines.
So they wanted a bunch of information about your vendors and your customers and what you were selling. Yes.
Yep. They wanted to know what I was selling, who I was selling to, and exactly what I was selling. So, or who I was buying from. So we provided all the information, and it was 6 months later. So I got a huge fine saying I broke the law selling Hondatas, and they weren't going after Hondata. They weren't going after anybody else. But I went to social media, obviously, and let everybody know what was kind of going on, talked to PRI, started learning a whole bunch about this EPA stuff. And now I think I'm pretty versed, but I've been fighting all of that fine still, and I still am, because I was able to prove that every one of them I sold went towards a competition vehicle, which is what their rules are. Like, here's a statement from the EPA on where they're at. The EPA certified motor vehicles cannot become non-road vehicles even if it is used exclusively for competition, because the definition of motor vehicle hinges on the purpose of its design and not its use.
So that's getting very, very picky about what a motor vehicle is and what it can be.
Yep.
Okay, so there's so much to dive into here that's just making my head spin. So let's try and kind of rationalize all this. So, okay, the Hondata was the product that they chose. So there's no kind of onus of proof that product was being used in an illegal way, because while admittedly using an aftermarket ECU of just about any generation and still meeting emission standards, in some instances impossible, in some instances possible but difficult. So I'm not going to get into that, but no burden of proof that this product was actually being used in a way that circumvented emission standards anyway by the EPA. That was just assumed.
Right, it was assumed. I had just sold the products on our website. Like, it was just, buy from somewhere and send somewhere. It wasn't like I was putting tunes in them. I wasn't putting them in, for that matter. It was just selling them.
Okay, so the next thing that kind of follows on from that is, would it not make more sense? Again, I'm obviously not a lawyer, I'm not the EPA, but I would have expected it, if you were the one doing the tunes and you were providing clearly emissions defeat tunes, yes, I accept that. For a road car, there's probably some liability there, and I get that. But you're just on selling this product and someone else is doing the tune, but they're not the ones liable, it's you for selling the product. And then the next step from that is, as you've mentioned, is not Honda they're going after, it's you as the reseller. Did you get to a point of understanding why it is they're going after resellers as opposed to the original product manufacturer?
No, honestly, and I'm still trying to figure that out. Whether it's to just put fear into this industry or, change it to, I still don't quite understand that part of it. I don't understand how us buying or selling the products is illegal in any way. I mean, that's basically how they're treating it. Is if I was to sell, any tuners for that matter, if it plugs into an OBD2 port, it's wild. I mean, they just got some Subaru shop last week. I was talking to the people at PRI. I'm not sure which shop it is, but they were even getting dinged for tunes with EO numbers, which is the exemption tune numbers. So In our world, we're assumed protected, and able to sell, but evidently not that either.
It's a scary time to be in the aftermarket industry, particularly if you are unfortunate enough to be in the US. You ended up with a pretty substantial fine over this. Can you talk to us about what that fine was? And I understand the EPA basically put two offers on the table, one much more attractive than the other. So let us know how that went down.
Yeah, they told me give us $18,000 now, and if you don't within this time frame, you're liable for $180,000.
So just the good old 10x rule. Okay.
Exactly.
No discussion around how they came to those numbers?
No, I've heard different things, but I don't really know how they came up with those numbers. Not at all. I'm not sure.
So I guess at this point, I mean, I'm guessing as a smaller shop, you're probably not just stacking gold bullion out the back. And $18,000, I know when I was running my business, that would have been a substantial hit to my tuning business.
Oh, yeah,
it's not.
absolutely.
We're not talking chump change here.
No, and
so
I'm still in that kind of neck of the woods. I still work for a living, and this stuff isn't like most of the time. If you had a shop, you're solving problems. You're just trying to make it run in general first. You haven't even got to making sure everything else works. It's just making the cars run, and then from there. So any kind of that, and you're not making that kind of money to pay those kind of fines. So it was huge, and I have been told that was probably the lightest fine anyone's ever heard about from the EPA. Most of them
I have heard of much larger fines.
Yeah, hundreds of thousands to millions. So
at this point, do you engage a solicitor and go down that path, or is it just pay the fine, move on?
I have been a lawyer. I'm not paying the fine. I don't believe I did anything wrong, and I don't believe any other shop like mine is doing anything wrong. In my thought process is, if I don't stand my ground, then somebody else that I've taught or shown how to do this, they could be dinged someday too. So, no matter what, I'm not paying. I'm working towards a solution that helps everybody.
Now, I mean, I don't want to stand here as well and say that emissions is something we should be ignoring. Obviously, there's some things going on in this world with climate change, and there's some responsibility that lays on our shoulders, anyone who is modifying cars. But I do see a distinction between what we do on the street and what in essence is a microscopic percentage of the total number of cars when we're actually talking about dedicated race cars. So I can certainly see this distinction between those two. And from what I understand, there is some moves ahead with the RPM Act to try and kind of get some clear guidelines on what we can and can't do for dedicated race cars. Can you give us maybe like the 30,000 foot view of what the RPM Act is and where that is at?
So the RPM Act will protect basically shops like mine where we're building competition vehicles and we're taking a VIN numbered car, a motor vehicle, and we're converting it to a race car. It'll protect you doing that. And that is, I think that's step one to all of this. And education can't stop as well. But the RPM Act will help protect businesses from any type of EPA action like what's going on with me right now.
Does this also influence the type of cars you would consider working on? I mean, obviously, if
Yes.
that RPM Act goes through, you've got this freedom to work on dedicated race cars that will never turn a wheel on a highway or a freeway. That's one thing. So does that mean that you would clearly just, I'm not working on any road-going cars, that's my line in the sand?
And that is where we're at right now. Here at the shop, that is primarily what we're doing. I mean, we started our own little race series even so that these guys got a place and an outlet. I like to compare it to like when I was young, we were into skateboarding and riding bike, and we would do it everywhere, street skating, and we would, we'd ride everywhere. And that became a big problem and was facing, criminal stuff. And then they came out with the skate parks and we got off the street and, we were at the skate parks. So where the future I see a lot of this is that type of thing. We need motorsport parks where we can drift and drag, road race, tune our cars, build our cars, and it'd be a safe environment away from the street, away from prosecution, away from all the negative side that goes on with the industry. If we can give some kind of outlet, it'll become the norm, and that's where I'm trying to go.
Yeah, definitely. I mean, I grew up with the normal sort of things that young guys into cars end up doing, and I got through all of that, and now being maybe a little bit older and a little bit wiser, I do see the benefit of providing an outlet that is safe and legal. And unfortunately, at least here in New Zealand, that's becoming increasingly difficult to do, and not all major centres have that, which is unfortunate. So while that's the case, I mean, clearly you're always going to have a street racing element, which just ends up putting our sport into disrepute and ends up causing those sort of negative social media attention, which we all want to stay away from. We'll move on from the EPA because I don't want to sort of have this whole podcast sort of on a downer. But where is that RPM Act at? Is it likely to pass, and if so, how far away is it?
So right now, it's up to the chairman of Energy and Commerce out of New Jersey, Frank Pallone. We need him to take it down to the House floor and to make something happen. So any New Jersey racers out there, I mean, we need you guys to be contacting and letting them know this is our livelihoods and this is our passion, and we need him to do that.
Yeah, 100%. I can only hope that that will move forward in time. All right, so let's get on to brighter topics and Honda engines. We've kind of already touched on the fact that they're a really good platform, even in stock form, to learn how to tune on. They're relatively strong and forgiving, I guess is the term I'm looking for. But things get a little bit more exciting when you start adding boost, and before long you're going to need to start upping the ante with the internals. So there's a range of different engines that have gained popularity. Obviously, there's the B series. Every time we post anything on our SR-powered 8.6, we inevitably get 100,000 Honda lovers in the comments saying we should have K-swapped it. No argument, actually, either from me. I love the K series. But let's awesome. Start with the B series. Obviously, it came before the K series, and it's still a very active market of people modifying and building those engines. And as far as I understand it as well, at least as far as sport front wheel drive goes, the B series is still actually the engine of choice over and above the K series. Is my understanding correct there?
Yeah, it is. And
why is that the case?
A lot of it goes to the kind of torque the K series makes and managing that with the gear ratios that are available, the exhaust housings and exhaust size exhaust size wheel, the turbine wheel. Those kind of need to be developed some still for the K series because it flows so much air, choking them out. It happens quick, especially once you start turning 11,000 plus RPM, they start nosing over. The gearing isn't quite right for it to be stretched out like we are. So I think as, exhaust housings get bigger and if they're allowing different size turbine wheels, we could, or even a way to just flow a little more, not to choke it out, you'd see some super fast times.
I guess when you look at that sport front wheel drive class as well, it is a control class in terms of the turbocharger, so there's some limiting factors around there. When you talk about the torque of the K series, I'm guessing there what you're talking about is that the torque is over and above what a B series will produce, all things being equal, and that can be enough to overcome the traction of a front wheel drive chassis?
Yeah, it can. And obviously we're all doing cuts and trying to plot dots and get it managed. But it still seems like, stuff could be better. Just bringing the power, dulling the power way down, and having a stretched out first gear would probably help any cars with a K series a lot.
All right. So what goes into building a really bulletproof B series? If we're talking, north of a 1,000 horsepower, what are you going to need to consider there? Because in the mainstream, we're now seeing more and more billet block options coming out. But the B series seems to actually do pretty well with the stock block, which is pretty impressive.
Yeah, it does. I mean, and they're still pretty basic. Some guys stud the mains, but stock bolts will still hold it. A set of cylinder sleeves and some L19 head studs, and step deck it or O-ring it, and that's basically still the same combo.
So the sleeve though, really that's kind of the key there, because the B series block is an alloy block and it's open deck, so there's a limit to how far you're going to get with cylinder pressure there before things start moving around, and ultimately you're going to crack a liner. So that's kind of the key modifications for reliability there. Yep.
The sleeve is the key for sure.
Okay.
A good tough sleeve, and we've been dry decking them as well, just in case you do push a gasket, you don't end up ripping the blocks in half like we did in Jamie's car.
Well, we'll talk about that in a moment, because I did want to dive into that. It's not something you see every day, but for those who aren't aware, that term dry deck, what are you talking about there?
The two halves between the cylinder head and the block, I mean, you don't allow any water to come through there. So you just reroute the water in the block and out of the block and through the head and out of the head instead of having it transfer between the two.
So the advantage there being that if you do end up lifting a head, blowing out a head gasket, you're not going to push combustion pressure into the cooling system. And I think the other aspect of that is, it's not just the mechanical aspect that we need to consider. There's a safety element there for any race car, but particularly in drag racing, where that can, in a roundabout way, end up getting water under the tyres, which is the last thing you need at maybe 150 mile an hour.
Yeah, exactly.
All right, so we've talked a little bit about the B series, and while obviously yes, at this point the sport front wheel drive haven't sort of jumped on the K series bandwagon. I mean, for me, having tuned dozens, hundreds of different engines, I think I still come back to the K series that I believe is probably the ultimate 4-cylinder naturally aspirated cylinder head. Like I have not come across anything else that really comes close. Maybe the Nissan SR20 VE cylinder head, but I'm a bit biased there because of our own race cars. So what other than that head, where are the pros and cons of the K series versus the B?
I mean, the K series, the B series is easier to work on, obviously, with the timing belt and that kind of stuff. They can come apart and go together so fast. In between round stuff is nothing. The K series, there's a little more to it, gluing and prying stuff apart. But for flow, the K, just like you said, for all naturally aspirated stuff, it just flows so good. The cylinder heads they put a lot of time in designing it. You can put big valves in it, big pistons in it, so the room to grow is wonderful in it too. And there's rooms for big cranks, and where like the B series, even a 95 millimeter stroke is tough. And I've heard of guys doing even more offset grind and bigger stuff, but you really end up grinding way inside the block to make swings, and then having enough deck height to actually have the piston work right, and rod ratio, there becomes so much involved with it that the K is just awesome in that way.
I think it's easy to overlook, but sometimes bigger in terms of capacity isn't always better. And when you're negatively impacting the strength of the engine architecture in order to get a little bit more capacity into it, that sometimes is it's not going to last that long. And I mean, obviously with the K series, there's a ready path to go K24 as well. So that's a pretty good way of getting some capacity into a K series to start with. Interesting point you made there about the maintenance aspect and being able to actually physically work on them, because I think that again is something that's really easy to overlook, particularly in a drag application. Best intentions aside, we're spanning on these cars, wrenching on these cars between rounds, and sometimes that wrenching is significant. Maybe you're swapping out a head gasket between rounds. So the ability to do that quickly and easily, that makes a massive difference whether you're going to make that next round when you're working on a tight time frame. The other aspect with the K series, which is an obvious benefit, is it runs the conventional VTEC mechanism but a continuously variable intake cam. Now, in a road race application or a street-driven car, that's a godsend. The ability to swing that cam is great. But I mean, if you're looking at an all-out drag engine, which may only run across a narrow rev range, maybe sort of, let's say, 8 to 10,000 RPM, is that in your opinion an advantage there, or is it basically a moot point?
The VTC, in the drag race application, I would say it's a moot point for sure. Because like you said, you're trying to narrow that window up anyway. As the turbos get bigger, you want tighter gears and more of them. So it becomes a moot point for sure.
Okay. When people are looking at selecting engines for a potential build, obviously we've got the B and K series. There's the F20C as well out of the S2000, which sort of seemed like a bit of a precursor to the K series for a rear-wheel drive application. I mean, it makes a lot of sense. That's what they came out in. But can you give us any advice on pros and cons of the F20 versus the K series, and where you'd choose one over the other?
I'd still choose the K, but I do have a love for the F20. The F20 is way easy to work on cam-wise, so if you needed to swap cams, do it really fast. The engine flows so much air, almost too much air for its own good, honestly. but it sings. The Fs have gotten so expensive right now that's probably the biggest deterrent of doing a lot with that engine. For my own race car, I have an F in it right now, and I have, I think, 3 heads and 3 blocks. So it's like, everything kind of has to be taken care of. Where the K, a few $100 and you can have any block, and the blocks are all pretty much the same, except the K24 is a little taller deck, but all the K blocks are pretty close. So they're just cheap. And that's a big part of all of this as well, is just keeping it within your budget. Because if you're racing without out of your means, you're not going to have much fun, and you're probably going to sit most of the time.
I think it's really important to just understand that, again, best laid intentions aside, sometimes things do go wrong. So the ability to source replacement components that aren't going to break the bank is pretty important. And I assume that simply comes down, that price of the F series simply comes down to they were never produced in the numbers that we see the K series being produced in. Yeah,
that's exactly it. And, the raddest is you use the K and you use the F crank, the 90 millimeter stroke, and then put it in a K24, and you can have yourself just a great rod ratio, high ripping, great engine. So, I mean, you can marry the parts as well and have the best of everything.
So there's interchangeability within the families there, even though there are differences.
Hondas are awesome like that. Yeah, you can move stuff around and make it all work. It's wonderful.
Okay, now you mentioned, you referenced Jamie's car earlier, and for those who haven't seen the video or the stories that went around Instagram a little while ago, it didn't end that well at a drag event in terms of the block splitting in half. I must admit, I've never seen anything quite so catastrophic with a Honda B series. So obviously we don't have pictures here. It's a podcast. Talk us through what actually went down.
Okay. Well, he got into the burnout box. He had a brand new set of slicks on there, so he was going to do himself a big burnout just to get the slicks ready to go. We had a big lofty goal for that week. We wanted to run 8s at every track and show we could do it in a front wheel drive Honda. So yeah, he put her in 3rd or 4th and let the clutch out, stood it up, and it made a whistle you wouldn't believe. But yeah, it pushed water out the front, but pushed water out the exhaust, and it didn't get out the burnout box. Once they got it back to the pit, they started diving in and trying to find out what happened. In the log, he saw that it flatlined the boost, which is 7-bar map sensors, 80 pounds. So we told the world it made 80 pounds, even though it could be well above that. But it cracked the block all the way around below of the head studs, and really became a 2-piece engine.
Yeah, I mean, it's pretty impressive actually. The video and photos that I saw floating around after that is the ARP head studs did a pretty good job because they weren't letting go no matter what. They were still firmly attached to the outside of the block.
Yeah, it really was. And I don't know. It probably blew the gasket between the cylinders when it was making boost, and that's probably what pressurized the coolant and cracked it all the way around. But it's fun to think that that it just blew it when it lifted just a little bit.
I mean, obviously there's a financial impact to fixing this, but I mean it is always pretty impressive when you're making big power. When things go wrong, they don't go wrong in a small way. So you've normally got a pretty impressive trophy cabinet of broken parts to show off to your buddies.
And it's not the worst break in the world, honestly. Let me tell you, like, everything in the block was still good, rods and pistons and cranks. So all of it just needs moved to another block, and we're going again.
Could always be worse. All right, the $1 million question though, what obviously, if we have a problem, that's one thing. What we need to do is diagnose and find out what caused the problem so that we can prevent it happening again. And obviously, you said it's flatlined at 80 psi, and for those who maybe missed that reference, the map sensor only reads to 80 psi, so it's flatlined at 80 psi. It's anyone's guess how far up and above 80 psi it was. So it could have been 85 psi, it could have been 140. We will never know.
We have no idea.
But what should it have been running? And then the obvious question is, how did it get to 80?
So in the burnout, it's set for around 40, 45 psi in that range. That's what the burnout boost is. It runs an E-gate. So once it gets to our set point, which was the 40, 45 pounds, it should open and then just hold the boost. Well, the PIDs were working super hard, but nothing happened. And the gate just stuck shut.
Okay. So no wastegating at all.
No wastegating whatsoever. It was just every bit that turbo could do.
Okay. Now, obviously, the TurboSmart E-gate is an electronic wastegate, so it does away with the pneumatic side of things and controls the wastegate electronically. And that product is it's not brand new for TurboSmart. I think we covered it a couple of years ago at PRI when it was just released, but it's got some runs on the board now. And electronic wastegate technology in general in the OE world is far from new. One of the issues we covered when that was released was the fact that it does have quite a high current draw requirement, a maximum of about 20 amps off the top of my head. And that straight away caused a bit of an issue for a lot of the aftermarket ECUs, particularly those dealing with the AMP Super Seal 1.0 connectors, in that the individual contacts through that connector are generally sort of 7-8 amps is about as far as you'd sort of push them. And then there's been a few ECUs that have come up with sort of alternative solutions, maybe an external driver box or paralleling two outputs. Anyway, so I digress, but how were you dealing with that? I believe that was running on FuelTech?
Yeah, it was running on FuelTech. It had their little control box as well. And, the FuelTech's nice, and how you can self-cal it, which, we were caling it before each event just to double check it. It had cowed earlier, so we weren't worried that it was stuck or anything. But yeah, through the FuelTech, we used it on the MR2 as well, and it worked flawlessly. We ran consistent 7s on that, and it went wherever we wanted it. And then in Jamie's car, the previous event, I mean, we made 5 passes and didn't have one issue. It was doing everything it was told. The car sat, it is humid there. We're not sure if that's anything to do with it or not, but it sat for a period of time. And then we came back out for that other event and first hit, went to the ceiling.
This is from talking to you before we started recording. This is still ongoing, so there isn't actually a resolution as such. So we're not chucking Turbo Smart under the bus here. It's obviously a case of working with both Fuel Tech and Turbo Smart to find out what happened.
To find out what happened exactly.
Yeah, make sure it doesn't happen again, because no one wants to go through that scenario twice. I mean,
even going back to that, I kind of would like to see, as these guys, as electric gates come out, we almost need like a resting point is open, instead of clamped shut, and maybe some type of curve to push it down and then ramp it in, I mean, there could be ways around this. We all just got to get kind of creative and play with those. So, I think maybe something like that's is something to look into, just in case there's a motor failure. It's not pinned shut, but maybe the resting's open.
Yeah, that's a good point, definitely.
Yeah.
All right. So in terms of the E-gate, because I haven't personally had a chance to play with one, obviously this aside, when they're working and you've got good control with whatever ECU you're controlling them with, why have you moved from a pneumatic wastegate to the E-gate? Where do you perceive the sort of key advantages?
Cleanliness, making them spool real fast, less plumbing, less stuff everywhere, I mean, that was the kind of, and besides the fact of learning the new technology and watching this tech grow and being part of all of that, I mean, it was really nice to watch as I pressed the throttle to watch the boost go up at the same rate as my foot. I mean, that's an amazing thing, not seeing lag like that. So, those kind of things just kind of sell you on it.
One of the key things I think that appeals to me, and particularly for a traction limited drag car, traditionally with a pneumatic wastegate, you're swapping springs, and you put, let's say, a 10 or a 15 psi spring in the wastegate, which maybe the car will leave the line pretty good in 60 foot width, but of course in the deep end you want 50-60 psi, and you can't get that spread with a conventional pneumatic wastegate. So yes, of course you can use CO2 boost control, which is a popular technique, but with the E-gate you've got no springs, and you basically tell the gate to do what you want, and you can get essentially just about any boost range that you want. So I think for me that's obviously a real big selling point. I mean, I've got to ask, boost cut would have maybe saved that engine?
It would have definitely saved it. And so there was always a cut in it before, and on the last event they started playing with things and they were worried it was going to hit cut during a pass, so it was still off from a previous event. But
it's not actually as uncommon as it sounds for people to switch off any form of limiters, and I know particularly in Australia where they're mad keen on their rotaries, and it's pretty common to run with no rev limiting, no boost cuts, nothing. They don't want the engine to touch a limiter because there's a potential for damage. So just to put some context around that, it definitely isn't unheard of. But hindsight's always 20/20 as well, as we like to say.
Yeah, and it was cool for pictures. But what I was going to say is I think another cool way to do the E-gate one day, would be to even have a 1-to-1 a back pressure type table, and then we can work on the traction control or slipper clutch taking care of a lot. But if you just kept the boost 1-to-1 the entire time, I mean, that's as much power as that thing can make. It's letting her flow.
I mean, yeah, it definitely, there's a lot of control options just around pretty much what you can dream up. So yeah, a lot more flexibility than a conventional pneumatic gate gives. Now, we've talked a little bit about the advances in electronics, and I just want to sort of dive back into that topic because it seems from looking at your content that you've sort of aligned yourself pretty firmly with Fuel Tech. And Fuel Tech, we've actually got one sitting on the shelf that hopefully, if I ever find some spare time, is going in our own FD3 SRX7. So I'm pretty keen to get some experience with that. We've had people crying out for course content on the fuel tech, and they're making some big waves, particularly in drag racing. So what is it about the fuel tech that sort of drew you down that path?
I think it's the simplicity of, I can help a client out with it, and then he's not stuck with me. You know what I mean? Once the table is built and things are done, I can teach clients how to use it, and they can go to the track and they're self-sufficient without, a bunch of trying to get a hold of me or any other help. I think that's what initially drew me in, and then once using it, any input can be any input, any output can be any output. The expansion, all the crank and cam options that you can, it's truly unlimited in those ways. And then it's, I always call it nerd speak, because the guys that write programs and the guys that are tuning them they're different dudes. They're different guys. We talk different, we think different. We say it, what it is, differently. So like even myself, I tune in Motec M1, which is just a phenomenal system, but it was a huge learning curve for me to reread and find what it was I needed to do to say what it does. Now I'm not talking against it, because it is awesome, but fuel tech, it's simple explanations, even the two-step, it says bang pop, so it speaks to the guys that have a passion to do this, that want to do this, but do not have the time to learn all that little stuff. And you're able to put it on a car and get racing that afternoon.
Yeah, 100% agree. I mean, the likes of the M1, and you've mentioned that, but not just to single out Motec. Yeah, it is a complex system, and you do need to understand their naming sort of mentality. And how they lay out the ECU, whereas a lot of ECUs, a little bit more maybe intuitive if you've come into it with just a basic understanding of aftermarket ECUs. Now, one of the other nice things with fuel tech is obviously they're not solely dedicated to drag racing, clearly, but they have put a lot of time into developing drag specific features, function sets, etc., which obviously works nicely with what you're doing. And I'm interested to just sort of know what in generally using, if any, in terms of the electronic functionality, in terms of launch strategies with a powerful front-wheel drive car, and anything in the way of traction control strategies if you happen to be using them as the car goes down the strip. Yeah,
absolutely. We try to get the best wheel speed sensors we can with as many teeth as possible, so we can just have control of the tire throughout. Most of the time it's through first and sometimes into second just a little bit, but it's just having that resolution, and then we'll plot dots on where the car's got like stepper rev limiters almost, so you'll hear it up, and then it's just getting a handle on how the tire's moving versus the wheel speed, and putting a whole bunch of weight on the front and let them go. I mean, that's basically how we're doing it. Plot the dots and let her go.
Plot the dots. Okay.
Yeah, and there'll be, and we'll also pull timing through those ranges, depends on how it's going. Boost, I'll vary sometimes, but most of the time I let the boost if I'm going to go down the track with 60 pounds, it's going to be 60 pounds at first, and we'll just tug that down because the limiters.
Okay. So you're basically feeding all of the boost in and then controlling the power output with timing, etc., other techniques.
Yep, exactly. Yep, it reacts so fast. Boost control stuff, just even though, like I said, we were on the E-gate, it's still slower. It doesn't react as fast, and it takes a bit to bring it back. So if you can just be there, you're good.
Yeah, and I think just from my own experience with the four-wheel drive stuff, which is somewhat similar in terms of, off the line, we're very much traction limited, and it's not till sort of third or fourth gear that the car will be able to put down everything it's capable of. But one way of doing that obviously is to step up the boost versus the gear. But when you're running these very large turbochargers on what is still a small capacity 4-cylinder engine, even with flat shifting, you still see the boost drop off considerably on a gear shift. So what that means is, if you're stepping the boost up, there's quite a significant time frame that you're losing as the boost comes up to your set point, no matter what boost control strategy you're using. So the advantage of having that boost in there rock solid the whole time, there's no delay in getting it up there, and then you're just using different techniques to control that torque until the tire will take it. Now, in terms of, you mentioned data logging and how important that's been to the modern ECUs, and I 100% agree. What are you looking at when a car comes back from a pass? What are you looking at in the data to sort of decide, all right, will the track take more power? What am I going to do for this next pass? What am I going to change in order to try and get a better ET, a better mile an hour?
It's, as soon as it comes back, you're kind of looking at your wheel speed versus where our cuts are. And then again, just trying to get that RPM and wheel speed to be more in line with each other as much as possible. You may get a little wheel speed up just to get the car moving, but to be able to manage that wheel speed and have full control of it. So you might bring it up and then have it tug down and then roll out. So the modern ECU and a log, we'll look at all of that. And then down track, like you said, how fast is the driver shifting, and then watching his cuts, and then just tightening the cuts up to what your driver's doing, and just getting every little ounce out of that. And the rest is just pouring power to it. So that's the easy part.
Power fixes almost everything.
Almost.
In terms of getting the car off the line and out to the 60, are you employing any clutch slipper units or slightest old clutches, or is it just the old-fashioned driver's left foot, and that's the slip control mechanism? And
it depends on the client, but we do love to use the slipper. The slipper makes things consistent no matter who's who's driving it. Some of the times where the client just has the little pill and you work around that. And then others, it is the driver. Like Boosted Boy Kyle is always the driver. So I'm always working on how his clutch is leaving and watching that. So, for me, it just depends on the client and how they're set up. And I prefer a slipper valve, and just to make it normal every time.
I found with my own cars that it's just so difficult, for me at least, to get consistency launch after launch if I'm just relying on my left foot. So the slipper definitely meant that I was getting the same launch every time, which definitely makes the car a hell of a lot more consistent. Now, let's move on. I want to talk about your son's car, Shane's car, which is another car that you're pretty well known for. This is it's a pretty cool little package there. CRX, but it's not like too many CRXs I've ever seen on the street. So you've converted it to all-wheel drive as well. And I mean, while I am quite certain that there's been a significant budget tied up in this car, it also looks more relatable probably to the average guy or girl in terms of it's
Absolutely.
Not clearly a sort of a $1 million build, is it?
No, not at all. Honestly, that car is mostly hand-me-downs. So like the engine is the H series out of the H22 Prelude, which is pretty cool. And all the internals of that came out of my old race program from the early 2000s. So aluminum rods, the Aries pistons, that kind of stuff. It was all stuff that I had for years. So he sourced a lot of that stuff that was laying around. And then we were in a car accident once and got a settlement. So we bought the transmission for it, So, stuff like that.
Why not?
Why not? It's a CRV all-wheel drive trans with all the PPG gears in it. So it's all pretty stout. But yeah, you package it all and put it in a little CRX, which the EF bay is probably one of the most difficult bays to work in, but it turned out really cool. Everything's been built here. Him and his friends have done it. Most of the work. Sean here built the turbo manifold, but he did it all. Didn't want my help very much. I got to tune it, but the rest he did, and it's pretty awesome, honestly.
Yeah, I assume that he's had a pretty fortunate upbringing with you as a father, sort of showing him the ropes. I assume that he's now sort of at a point where he figures he's learned enough from you, and that's why he didn't want your help with anything other than the tuning. So he's now learned enough from you that he's capable of basically building this car from scratch on his own.
On his own, yeah, that's it. Yeah, something he wanted to do, and yeah, it really is. The car belonged to a friend of ours too that was around the shop all the time, who passed away. So like him getting that car was like a big deal, and then he calls it Lizette because it's the light to him. So lighthouses are a big thing to him, and he likes to be positive. And I don't know, it just turned out really cool. All the stuff he did, make it all work.
So we didn't really touch on the H series. I don't want to sort of go too much further down that particular rabbit hole, but obviously it is what it is. In terms of the power and boost levels, can you let us know sort of what's it producing at the moment?
So at 26 pounds, it made 720 horse on the all-wheel drive dyno. So pretty good. At the track, his first time really out, it went 9.4, 147. And then on sick week, the first day, he went 9.6 at 151. So it makes decent power. He's 60 foot in the low 140s. And again, he's learning it. His foot's not the same. There's not a slipper on it yet, which is something we want to do. But he's learned kind of riding it out some. And just watching an all-wheel drive Honda leave, it's another world. It's kind of a game changer in some ways.
Yeah, we did have the opportunity to talk to Norris from Preonto Racing back at TX2K a while back about the four-wheel drive sort of thing. But I mean, what I'd sort of say is, 1.4 is probably not unheard of or not too difficult to achieve with an all front-wheel drive package. So do you see at the moment the four-wheel drive being an advantage, or is this sort of something that in its future, once it starts getting dialed and turned up, that's where the four-wheel drive is really going to come into its own?
Oh yeah, once it's dialed, it's going to be amazing. I mean, there's already guys that are bottom 1, 2, 60 foots with them. It's like you said, it's that learning how much power to leave with, what right viscosity fluid to put in the viscous itself, managing the power as it leaves. Just all of that stuff's going to start to really come into play. But right now it seems like, it'll let you leave with a ton. I haven't put a ton in it yet, but it seems like it'll just take it. I haven't seen it sit sideways yet when it leaves. So we've probably got a ways to go.
Obviously needs more power then.
Yeah, exactly. We haven't got there yet.
You mentioned the fluid for the viscous. So for those who aren't aware, this is the center differential, which provides the power transfer to the rear differential. So you can essentially change the amount of drive being sent to the rear by the viscosity of the fluid you put in that center diff.
Yep, exactly. You can change it that way, or you can also change it by putting a bigger rear wheel on it. Because they have a different gear ratio as the front. So any kind of playing with those things just helps give the car more of a push. And that's all it's doing, right? It's just giving the front wheel drive a push.
One of the obvious issues here is you've got 700 horsepower, as you mentioned, and you're putting this through a CRV transmission. I don't really know what CRVs came out with. I'm guessing it's probably 150 or less. So yeah, how are these production parts coping in a drag racing application? Because I mean, I've broken some parts in my time, and they were probably stronger than what you're dealing with. So yeah, how's that holding up?
So like he has done 1/460 foots with the stock transfer case, but right now he's got a billet transfer case, a billet front case, PPG gears. He's got strong stuff to help with that. As of the viscous, that's still stock, and the rear diff is still stock. So those handle the power pretty good. Honda didn't make total junk, but the axles, got to work on that stuff. But it is still, like you said, still needs some kind of slipper to make it work real good. But all-wheel drive, I mean, it's pretty awesome.
The good thing about drag racing is that it quickly lets you know what parts need upgrading. So yeah, I'm guessing there may still be a learning curve ahead as you go a bit quicker.
Yeah, you'll see. Just follow along for sure.
At this stage, I'd guess that for a built H series, 26 PSI, 700 horsepower, there's probably a little bit more on the table there. What do you sort of see that combination is capable of in terms of power, boost levels, etc. once it's dialed and you really want to start leaning on it?
So Boosted Boy Kyle here at the shop, we built this old Prelude, and it's literally the other spare engine that I used to run. So we've got a pretty good idea. That one made a little over 1,000 horse. So I could see Shane's being in the same neck of the woods, 1,000, 1,100 horse. And then, like you said, seeing what drivetrain can handle. I mean, obviously there's guys like Speed Factory that are already out there developing things, which helps the rest of us. So there's a lot of guys working on things, trying to make them better. The K-Series all-wheel drive trans seems to handle a lot once they've got a good gear set in them, you know. We run that Quaif in the minivan of the Boosted Boys, and that thing's been stout. That works really well. The B-Series one seems to need some work, but the guys are working real hard on developing that, so.
It is always a bit of a frustration with drag racing with production based parts. You know, you can put the best gear set in the world in, but I mean, at least in my experience, they aren't still ever 100% bulletproof. And I mean, that's no disrespect to PPG. I mean, when you are dealing with production components in general, there's limitations imposed. So there's only so much you can do, particularly when you take a factory component that was designed for sub 200 horsepower and make it 1100. I mean, your worlds apart. So there's an understanding there. But I mean, I for one never particularly enjoyed going to a drag meeting and ending up sort of on my back underneath the car, pulling the trans out, and inevitably getting covered in gear oil, which no one really likes. So that's one of the aspects from my sort of past, which I don't look forward to jumping back to. I'll be honest.
I'll be honest. I kind of have a passion for some of that thrash. I still do. Maybe why I'm in the Honda world so much, but I enjoy all of that. You know what I mean? I like to show that this thing can come right out and go right back in. It's no big deal. And it seems to inspire some of these young guys to just, like get out there and do it. Don't quit.
I think
make the next round.
One of the aspects there that's really important, and I learned this the hard way, is designing the car so it is easy to work with. So
absolutely.
What I'll sort of give my own Mitsubishi Evo 3, we tube framed the front of that, which was an exercise in frustration because we did it to save weight, and the reality is I think we saved all of about 10 pounds. It just didn't really give us what we wanted, and because we hadn't really thought the whole process through, the way the fabrication was done, if we wanted to pull the transmission, which was the part that always broke, or even if it didn't, every 10 passes we fried a triple plate clutch, so it had to come out every drag meeting regardless. You had to pull the engine out to get the gearbox out. It was a shit show. So we learned from that. We built an Evo 9 that claimed the late model Evo world record, went 834, 170 mile an hour, and we purposely thought this through, and we redesigned the cross member that supported the engine and tranny and that way we could get that gearbox out. I think the record for getting that out on a hoist was about 18 or 20 minutes. So you do learn from your disasters, and I think you're right. The never say die attitude, I think, is pretty important. Now, you've mentioned this event, Sick Week, which has only just gone down, and I'd like to get a bit of a quick rundown on what Sick Week is and what it entails.
It's a drag and drive event, which I absolutely love drag and drive events. You bring your race car, you and the co-driver, or the driver and co-driver, they're the only ones allowed to work on the cars. You have to bring your own tools, your own parts with you. And you basically try to get the best average you can. So like Sick Week was 5 different tracks. So every track you're trying to, run your best time and, get that average down there. And that's how you'd win it. But like I said, you got to go with a co-driver and trailer your own stuff. And, I don't know. It's super challenging and awesome.
What's the sort of the distance between tracks that you're driving overnight?
On sick week, it was probably around 150 miles or so. Like race weeks are usually between 200 and 500.
Okay.
So, it depends on the event. But that one sick week was just a ton of fun, just because our challenges, and we were in a brand new car that hadn't done anything like that, barely had driven on the street at all. So it was cool and a challenge. So.
Yeah, I've seen some of the videos on your channel from Sick Week, and it's obviously it's not import only. You've got a lot of domestics there as well. And I'm interested to get a bit of a feel from you on like what is the vibe like in the US with a import versus domestic event. I mean, I know when we first started import racing here in New Zealand, we were kind of like not really welcome at the drag strip, and it took a while before the V8 heavyweights kind of accepted us and grudgingly let us share the drag strip, but that was definitely something that took a while. What's it like in the US?
We've gone through those same growing pains, but now Tom Bailey has been super accepting of what we're trying to do and what we're trying to build, and it right now it's been actually pretty good. Our PSCA races are import domestic type events too that we're involved with. So it's growing. It's getting better and better all the time. For a long time they were looked at as, little cars that broke and blew up all the time. Well, the reliability, the ECU stuff's making that a lot better. Like you said, the slipper stuff and just learning to manage the tire and the chassis right. I think you'll see more reliability and us not pushing past our own boundaries that we kind of know. So it's us working with those guys and just having a good example, cleaning up after ourselves at the track, working hard. I think, us breaking things and fixing them at the track, those guys have given us a lot of respect for and our no quit attitude and all those kind of things, just knock it down. Those guys see we're car guys too, and that we're all in this together. We just chose a different air pump, and we love it.
I mean, I think from my own perspective, what I saw start to change the tide here in New Zealand was when a bunch of us actually started running some pretty quick numbers. And
yeah, there's that too.
At the end of the day, we're all car people, guys and girls, and something that runs a mid-8, for example, I don't really care if it's got 4 cylinders, 6 cylinders, or 8. I mean, there's some respect that goes along with that, because everyone knows that is a struggle no matter what the platform is that you're working on. So I think that's something that I saw change. All right, Brent, one last topic that I wanted to touch on, and we'll maybe try and get through this one a little quicker, because I know we've gone a bit long here already, but I just wanted to get some details around another project that I've seen on your channel, which is the PFI Speed Legend. It looks like you're bringing this back out. So for those, again, we don't have the benefit of graphics here, visuals, so tell us what this car is and what it's all about.
It's a 94 Honda Civic. Back in the early 2000s, even in the late 90s, it's one of those cars that we put together and we're racing IDRC with, and then NOPI, and then the NHRA, and we campaigned the car for a long time until the NHRA basically went away, and that's kind of when the car got shelved. It belongs to my good friend JJ, who, we raced together. He even worked here for a few years early on, he's always been a great friend and part of the family here. So he's had it stored and sitting. Tony Paulo, who pretty well, he, the last time it got some work done, he set it up with the X-Track transmission, Motec M800 and everything. And we actually never got to run it with the setup. As the car sat from about, like I said, 04, the X-Track went away. Some stuff has been picked apart, and has gone away. And we've all been talking, and we got the wild hair to bring it back out. And my son, Steven, who last year built his own little Civic, and honestly, it was his first year ever going drag racing. He went from running 12s to 10.3 And again, doing it, a lot of it on his own, with a little engine he built out in the dirt parking lot, which, it's kind of cool.
Impressive.
But he put it together himself and did it. And 1030. But he's gonna pilot it this year. He's kind of just, he's got a super big passion and love for it as well. So it's kind of cool to bring an old car back. Back in the day with the Liberty transmission, which was a 4-speed and a B-series engine, it went 847, 174 miles an hour. So, it was pretty quick back then in the hot rod class. But with today's technology and turbo stuff, and, I just want to see what we could really do.
Where do you see that going? Because I 100% agree. The biggest thing why I'd like to have my time again with my old drag car is, we were stuck with HKS T51R ball bearing turbo, and it was if you want lag, you've got it. We didn't really make any boost until the factory rev limit of a 4G63, and then from 7.5 to 11, it was hold on. But the technology in the modern turbos, I'm still blown away just how good they are now and how much response they can provide as well. So where do you sort of see this going? Are we looking at 7s?
Yeah, that's the goal, is 7s for sure. I'd love to say a mid-7, but I want to start with getting it into the 7s. We've got a pretty good program for that with the fuel tech stuff. So I think we can do it for sure. So that's definitely the goal.
Okay. Now, there's a couple of other things that are real standouts on this car. Obviously, the front end is tube framed, and it's obvious. Go watch a video after this, and we'll put some links in. But the way the engine's been moved forward and leant forward to get all of that weight forward of the front axle line, all of the engine mass is forward of the axle line, which makes a lot of sense on a front wheel drive car. One of the aspects that's obvious again is that it's dry sumped. And we went through that as well on my own car. We dry sumped that. We actually were having issues not down the drag strip, but it was more with oil surge when we pulled the chute at the end of the strip. However, the Evo 9 that we then built that held that late model Evo world record, we stayed wet sump with that with a pretty well developed baffled sump. So with drag racing, because we're accelerating and we're braking, so we do have a lot of control over the G forces that the engine's subjected to. These days, if you were to build that car, would you straight away go dry sump with the cost and complexity that involves, or do you think you can get away with a wet sump setup?
I would prefer like a wet sump type setup with still an external pump on a B series, to be honest with you, just because the oil pump gears can shatter so easily. 4 cylinders are inherently unbalanced, so you get this crazy vibration through everything. So I don't know. I think I would still like a wet sump type setup. I don't know if I'd go dry sump still, but this setup's kind of going to stay that way because obviously what we've kind of built. But
you've got it. You're not going to get rid of it. I'm just interested
exactly.
If you felt that was an essential.
And with this car, we never had any dry sump or oiling issues. We always pre-oiled it before we started it. Pull the belt. Run oil through it all the time, and then obviously having some kind of pressure controls and stuff, and just safeties.
Sure. The other aspect is back in its original guise, it looked like it was non-intercooled, so I'm assuming it was running on methanol fuel back then. And you've talked in your videos about the fact that you are going to be adding an intercooler and moving the fuel cell to make room for that. So are you staying on methanol and the intercooler is your preference, or are you dropping back to something like E85?
I'm gonna keep it on methanol. I still prefer methanol, and from my own experiences of playing with methanol, even there's still some advantages to having it intercooled. So I'm I don't know. I've kind of become my own believer just from my own tests on other projects and other stuff, that you can there's still a decent advantage to intercooling even with methanol.
I personally ran intercooler with methanol, and I think if I build another engine at that sort of power level, I'd probably stick to it just because I know it and I trust it. But it is one of those, there's a very split opinion out there, because you walk around the pits of any drag event and you'll see as many methanol boosted cars running with or without intercoolers. So it's definitely, I don't think it's a guarantee that you have to have it, but just interested to get your perspective on that. Okay, I mean, we could talk another hour on that car alone, but we're going a little bit long, so I think we'll move towards closing this thing off and letting you get back to work. We always like to ask the same questions to every guest at the end of our show, and the first of those is what's coming up for you in the future. What's next with PFI Speed? Where do you sort of see yourself going? Any cool projects in the mix other than the car we just talked about?
Yep. My own race car is showing enough. My little S2000's just about wrapped up. Just waiting for a drive shaft, which could be even today. So I'm pretty stoked about that. That car, I've got a low 7, high 6 second goal for, and I look forward to that. Racing more with my son Shane, and then having our own little PSCA events, because we liked our entire little racing community to get together. So we have four events this year at Vandermeer Speedway, where we'll have, all these guys get together with all their little front wheel drives or rear wheel drive cars, and we all just go out and race together and have a good time. So those are always fun. People can follow us up on the PFI Speed YouTube, always putting videos out there showing what's going on here and having a good time and trying to inspire others to do the same. And, that's where we're at. That's what we're doing. We're having a good time. We've got a bunch of cleaving car events again this year, and then a whole bunch of front wheel drive racing down in Florida. So we've got a busy year, and it's going to be awesome for sure. Sounds
like you're living the dream. And I mean, I think the other thing that is pretty obvious from what you've just mentioned there, it's not just going out and running PBs on the strip. It's definitely the social element of drag racing and the camaraderie that you build with a bunch of like-minded people that's really, really important. We're doing it because we're having fun.
Yeah, and that's what advances all this stuff. We don't have all the right ideas, but somebody else might interject and have something. And you know what I mean? We build relationships and we build we just keep pushing all this technology. Like you said earlier, it's not rocket science, but in some ways it is. And we're controlling these little rockets and having a good time doing it. So.
And always just keep an open mind about what other people are doing.
That's right.
All right. So, looking at what's sort of gone on in your career so far, and obviously your son Shane's following in your footsteps. Is there any advice you're giving to Shane now in order to sort of fast track his career and maybe avoid any of the potential pitfalls that you've come across?
I tell him all the time, don't get frustrated. You're gonna struggle with things, but just the clearer you can keep your head and the clearer you can just push forward, you will get through it. You will find the answer. And I think that goes a long way with everything we do, but just keep being motivated and inspired and push forward for sure.
That's good advice. And I mean, I know that there's always times when you're building cars, working on cars and racing cars that things don't go your way. The highs and lows of drag racing are intense, but trying to keep that in mind, it's definitely solid advice. Our last question for today, Brent, you've kind of already alluded to this as well. You've got a very successful YouTube channel, but other places that people can follow you. You're also on Instagram?
Instagram and Facebook. Yep. We're on Instagram, Facebook, okay. and YouTube.
All right. Well, we'll drop some links into the show notes as well, so people can follow those and check you out if they aren't already. Oh, thanks heaps for your time today, Brent. Really appreciate the chat.
Yeah, it's been so cool.
And best of luck with the EPA. We can only hope that works out well for you.
Hey, we'll keep on fighting. That's for sure. Love this stuff.
All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get 75 $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.